As mentioned in the email this video is attached to, imagine a 4 kilogram trash can. The trash can is disgusting, so you tie a string to it and pull on the string with a force of 50 newtons. The force of kinetic friction on the trash can while it slides is 30 newtons. The trash can slides across the ground for a distance of 10 meters. What is the work done by each force acting on the trash can as it slides across the ground? What is the net force acting on the trash can? What is the speed of the trash can after it has slid 10 meters? Well, the first thing I did here was draw a diagram to kind of illustrate what's going on in the problem, and it shows the trash can being pulled over a distance of 10 meters with an applied force of 50 newtons and a kinetic friction of 30 newtons. And then I drew a force body diagram to illustrate all the forces acting on the trash can. And these are the forces I'm going to find in this problem as well. Now again, to find the work done by each force, we should recall the formula definition of work, which is work is equal to Fd times cosine of theta, where theta is the angle between the force doing the work and the direction the trash can is moving. So there are four forces involved here, with tension to the right, the normal force pointing up, the gravitational force pointing down, and the force of the kinetic friction pointing to the left. In finding the work done for all of these forces, the displacement is going to be 10 meters, but the value of the force and the angle between the force and the displacement is going to differ for each of the forces. For instance, to find the work done by the force of tension, we'll plug in the size of the tension, which is 50 newtons. The displacement is 10 meters. And since the tension force is pointed at the same direction as the displacement, the angle between the force of tension and the displacement is going to be 0 degrees. And since cosine of 0 is 1, the work done by the tension force is 500 joules. To find the work done by friction, we'll plug in the size of the force of friction, which is 30 newtons. The displacement is still going to be 10 meters, and since the force of friction points in the opposite direction as the displacement does, the angle between the force of friction and the displacement is going to be 180 degrees. Since the cosine of 180 is negative 1, the work done by the force of friction is going to be negative 300 joules. Now let's figure out the work done by the gravitational force. The force of gravity is mg, so the force of gravity is 4 kilograms times 9.8 meters per second squared, which is 39.2 newtons. The displacement is going to be again 10 meters, but the angle between the gravitational force and the direction of the displacement is going to be 90 degrees in this case. And since cosine of 90 is 0, the gravitational force does no work on the trash can. And also, if we look to find the work done by the normal force, the angle between the direction of the displacement and the normal force is 90 degrees, so the normal force also does no work on the trash can. This makes sense because forces that are perpendicular to the motion can never do any work on that object. So that's how you find the work done by the individual forces. Now what we're going to do is find the net work done on the trash can. So all we do is add up the work done by each individual force. So I got the net work to be done as 200 joules. So now that we know the net work, we can use this and the work energy principle to figure out the speed of the trash can after it has slid the 10 meters. So the work energy principle says that the net work done on an object is equal to the change in kinetic energy of that object. So 200 joules is going to equal the difference in kinetic energy. Now if we assume the trash can started at rest, which seems pretty reasonable, the initial velocity is going to be 0. So we can solve for the final speed of the trash can, which comes out to be 10 meters per second.